calculus 2 under the topic of exponential function. In calculus 1, we look at how to differentiate what? Exponential functions. And in calculus 2, we are going to look at how to integrate what? Exponential functions. So please make sure go back and watch your calculus 1. Okay, we are saying that an exponential function e is a constant, alright? It's a constant. But when we introduce an exponent of a function here, whether s or u, it means it makes everything here what? A function. So when we are doing differentiation, and don't forget, integration is a reverse process of what? Differentiation. So we learned that integral of exponential functions. We learned that when you differentiate e to the power s, you are going to get e to the power s. In the same way, we can also multiply both sides by e to the power s so that we get e to the power s ds. And when you integrate both sides as respect to ds, when you integrate both sides, it's going to undo this what? Derivative. Then we get e to the power what? S is equal to integral of e to the power s ds. So what this means is that integration is a reverse process of what? Differentiation. So when you integrate e to the power s ds, you are going to get e to the power s plus c. So that is that for that. Alright. Hope this is just a simple. When you differentiate e to the power s, you get e to the power s. When you integrate e to the power s, you get e to the power s. Alright, so now let's look at it generally. Okay, let's look at it generally. So in general, here it's not always that here is going to be s for you. Alright, it's not always that it's going to be s for you. So you can get it e to the power u. Okay, u. And that one, when you integrate, you get e to the power u plus c. But you need to go and what? Set the function. Don't worry. Let's look at this example. Looking at this example, we have integral of e to the power 2s ds. So if you have e to the power 2s ds to integrate, first of all, note that the exponent here, the power here, is not x. So we need to go and differentiate what? That. So like it means that in general we can get a constant to attach with the what? To the x, or it can be a whole what? Function. So let's consider ax. Okay, so you set u to be equal to ax, and when you differentiate this, you are going to get a. So ds, because we need to go and do substitution part, use substitution. So ds is going to be equal to du over what? A. And when you do the substitution, you get e to the power u. Then ds is what? Du dA. Alright. And the a here is a constant. So you get 1 over a integral of e to the power u du. I hope you can see that. Alright. So now, when you integrate this, this is the same a over a, but when you integrate e to the power u, you are going to get e to the power u plus c. Simple. So anytime we get addition of a constant or the coefficient here, if it's 2, you are going to get 1 over 2 of that, and that's how it's going to be. So what we mean is that if you have the integral of e to the power 2s ds, simply we are going to get the result of 1 over 2 e raised to the power 2s plus c. And that is exactly what this concept is telling. I hope it's clear. So with this, if you want to go by the steps, no problem. But for me, I'll just go it and go my way. E raised to the power 5s ds. It's just 1 over 5 integral of 5s plus c. We can also set u to be equal to the 5s and so, and you are going to get exactly as what I'm saying. Alright, but it's not always that you can get that place to be a constant and a variable. Sometimes everything will be an embedded function. Everything is going to be a function. Let's look at this question. Here we have integral of e to the power 2 over s, all this over s squared ds. So having a question like this, you see, it's not in this form. Alright, it's not in this form. It's not in this form, so you cannot just do anything like that. So now we have to do something for it to come in a proper form so that we can integrate and go our way. Alright, so the first thing to do is to look at how you are going to set your u, because setting your u is very, very, very important or necessary. We are going to pick u so that the differential results, the variable or the whole results will be inside of the integral function. So you can see that if you set u to be equal to 2 and s squared, the differential is going to give you 2s, and 2s is nowhere in the what? And even the 2s, the s can never cancel what we have here. So setting u to be equal to this will not help us. Then let u be equal to 2 over s, which is the same as 2 negative 2. So du ds is going to be equal to negative 2s. And this is differentiation, right? So what we are doing is that you multiply the power by the coefficient, subtract 1 from it, and you get negative 3. So this is going to give us du is equal to negative 2 over s to the power what? 3. I hope you can see from there. ds. So let's make ds the subject. Let's make ds the subject. Alright. So if we make ds the subject, please sorry, here is supposed to be power 3. Alright. So when we make ds the subject, ds is going to be equal to, just by d cross multiplication, alright? So let's maintain this one here. So when you do cross multiplication, you are going to get s cube du is equal to negative 2 ds. And now, to make ds the subject, we get ds is equal to negative 2 over s cube. So, by substitution, we are going to get integral of e raised to the power u over s cube times ds is what? Oh, ds, sorry, ds is going to be equal to s cube du over negative 2. Alright, when you are getting it wrong, you have to see it because at the end of the day, this and this have to cancel. So the substitution is going to give this. So this and this will go away. What is the constant in here? 1 over negative 2. Alright, so having this, we get e raised to power u du. You see that now we have been able to transform these to what we know already. Very good. So here we are going to get negative 1 over 2, and when you integrate this, you get e raised to power u plus c. But we know that u is equal to what? 2 over s. So by substitution, we are going to get. So by substitution, we are going to get e raised to the power 2 over s plus c. That is that for that. Very good. Hope you are following. Trust you. Alright, let's look at this special case also. You can get e raised to the power here, picking u is also very important here. Now, what do you think we should let u be? I'm sure you are saying we should let it be e raised to the power negative s. But do you know something? You cannot set u to be e raised to the power negative s for both of it. When you do it like that, you haven't changed anything, and it's going to be somehow complex for you because you'll be having something like u over 1 plus e raised to power negative s. That will not help you because after setting u to be equal to e raised to power negative s and differentiate it, the thing is going to bounce back again, and what is it going to cancel? So let's try this and see. U raised to the power 1 plus e raised to the power negative s. So du ds is going to differentiate it. You get negative e raised to the power negative s. Hope you can see that. Alright. So when we make ds the subject, we are going to get du over e raised to the power negative s. So by substitution, we get integral of negative s, all this over u. You see that? Now we are getting everything here to be u, but not something like 1 plus u, like how you, in case you do it, u is equal to e raised to the power negative s. That's not going to help you. And here, by substitution, negative du over e raised to the power negative s. Clearly, you see this is going to clear up this. Beautiful. Oh, I love this. And when such happens, you are going to get the constant in here is negative. So we are going to learn the integral of 1 over u du. So we get negative u is equal to negative 1 du. So when you integrate this, what are you going to get? You don't, first of all, you don't even need to break it this way. You know that 1 over u is just plain u, alright, plus c. But U is what? 1 plus U is equal to negative S. Therefore, negative ln 1 plus U is equal to negative S plus C is going to be the integral of that. Interesting. Alright. Oh, we can still continue with it. Okay, we can still continue with it. Here, we can leave our answer in ln 1 over 1 plus e raised to the power negative x plus c, so that this negative will vanish. Thank you, and that is that. Or, furthermore, we can even make here ln c, because ln c, don't worry, leave it like this. Alright. Next question. Wow. Interesting. Integral of e raised to the power negative s sec e raised to the power negative s. Yes. Here, bear in mind that this sec e raised to the power negative s is an argument. And argument is not the same as this. Argument is an angle, alright? And that is not the same as what is here. So here to say to you, we know that your u is always inside of something. Yes, I agree with you. But the u e raised to power negative s, that's the u. Your target is the argument, or is this your target? Then let me tell you, if your target for setting u to be equal to e raised to power negative s is this, there is no way that you can use e raised to power negative s to go and cancel the argument inside of it. It can happen. Like sin e raised to power s over e raised to power s, then you say this will cancel this. Ish! This is not this is the problem of what? Algebra. This is not unique calculus, this is algebra. Alright, so that can happen. Du ds is going to be negative e raised to power negative s. Okay, so ds is du over negative e raised to power negative what? S. Alright, so by substitution, e raised to power negative s, don't forget, it's not u. Then it's sec u. Then ds is going to be du over e raised to power negative s. Don't forget this negative will come out. Slow down today, don't worry. This will cancel this. The negative integral of sec u. Now you see, we have gotten it in a proper form. Something that you know already, alright? So, what is integral of sec u? What is going to be integral of sec u? If only you have watched the video under integration of natural logarithm, you should be able to tell me that. So what is going to be that? Make sure you write that down. Okay, so when you integrate sec, we learned that I'm coming. Okay. Alright, so that is going to give you ln sec u plus tan u plus c. But you know that u is e raised to power negative s. So sec e raised to power negative s plus tan e raised to power negative s plus c. So that's going to be your results. So with this, just leave it like that, okay, and go your way. Our next example is also interesting. Our next example is also interesting. We have integral e raised to power s ln e raised to power s plus 1 over e raised to power s plus 1 ds. Here, even though you have the concept that the u is always inside of what? Something. But here, if you set the u to be equal to e raised to power s plus 1, you cannot say that here is e raised to power s plus 1, here is e raised to power s plus 1. So you are letting here and here be equal to u. When you do that, like it's going to be somehow tedious for you, okay? Because at the end of the day, you end up confusing yourself. But let's look at something. If we set u to be equal to ln e raised to power s plus 1, yeah, you know how to differentiate it, so no problem. 1 over e raised to power s plus 1, then times what? The differential of e raised to power s plus 1. That's the differential of the inside. So here you are going to get, here when you integrate, when you differentiate this, you are going to get e raised to power s. The one is over this, e raised to power s plus 1. Now, you can see that our result is embedded in the integral function. And when you set u to be equal to only this, you only end up getting e raised to power s, which is not going to help you, as I said. But with this, you can get e raised to power s. Here, the whole of that is u over e raised to power s plus 1 ds. You know that ds is what? So when you make ds the subject, you are going to get ds to be equal to this times this. So e raised to power s plus 1 du over, so e raised to power s. And when you do that substitution, you are going to get e raised to power s plus 1 over e raised to power s, alright, du. So you can clearly see that this will take away this, this will take away this. Beautiful. I hope you can see how it is. So you get u du. Alright. That's it. And when you integrate this, you get u squared over 2 plus what? C. But u is what? U is ln e raised to power s plus ln e raised to power s plus 1, and we're going to get the whole of this square. All these over 2 plus c. So that is going to be the results for that. Good. Love mathematics. Hope you also. Right, so now let's go to another special case in the natural logarithm. Now, if we are saying that e raised to power s is a constant, a natural log of e is a constant, and when we introduce a function here, it makes everything a function. But don't forget that when you differentiate e raised to power s, you get 0 because it's a constant. Then we have to also learn how to, like we did in differentiation, we learned how to take the derivative of what? A constant. This can be 2, 3, or whatever. And when, in case we have, let's say 2, and we introduce a function here, or a variable here, it makes everything what? A function. So in such case, as we did in differentiation, we can also do the same thing here. So for instance, in differentiation, we said that if you have a representing any constant raised to a power of a function, and when you differentiate this, they are saying that you get ln, you take ln of what? The constant. And when you take the ln of the constant, then you repeat a to the power u, then you multiply by du dx. We established this under calculus what? 1. And I hope you remember. Alright. It's a reverse process. Okay. So now in integration, this is in differentiation. In integration, if we integrate a raised to the power u du, we end up getting a raised to the power u over ln a plus c. So you can see that here the ln a that you take, you multiply by this. But here the ln a that you take in integration, you divide by it. Okay, that's the only difference. Then you add what? The plus c. That represents family of what? Constants. Family of what? Constants. Alright. So therefore, let's try some questions and see. To integrate 3 raised to the power s dx, what are we going to get? The first thing to do, as we did here, is to repeat the whole thing. And after repeating the whole thing, then you divide that by what? Ln. You divide that by what? Ln of the constant, which is what? 3. Then plus what? C. But here, please remember that the function we have here is the function we have as an exponent here is x. And when you differentiate x, you get 1. So it will not affect anything. Don't forget that. Alright. Let's look at example like this. Let's look at example like this. Integral of 5 raised to the power 2x squared ds. Having this in the same way, here we need to set our u, and that is going to be, let me clear all this, and that is going to be 2x. So du ds going to be 2. And ds, now, why is it that here I'm setting u to be equal to the power there? Because here it's not just x. When you differentiate the results, it's not going to give you 1. So it will affect the final thing. So ds is going to be equal to du over what? 2. So when you integrate this, 5 raised to the power u. ds is du over 2. Now, we want it to be in a proper form like this so that we can take our integration. So here we haven't done integration yet. Here the constant thing is 1 over 2. And when that comes out, we get 5 u du. And we are now in this form. I hope you are getting this. And if we are now in this form, then the thing becomes simple. 1 over 2. Repeat this. Divide by what? The ln of what? This is just a constant. The half is a constant. Alright? So now, to integrate that, you repeat 5 raised to the power u. Then you divide by ln what? Ln 5. That is the constant. Then you add plus c. So in all, we are going to get 5 raised to the power u over 2 ln 5 plus c. Alright, so by substitution, we are going to get the u is 2s, so we get 2s, and that is that. Alright, so if we have established that, if we have, let's say, a constant of 6 raised to the power 2x, it's going to follow the same thing, but the coefficient here is where you are going to take 1 over. So if you have 3 raised to the power 7x, you get the same way. You repeat what? 3 raised to the power 7x over the ln of what? The 7. But here it's going to be 1, it's going to multiply by 1 over what? The 7. So don't forget that. Thank you. What if we have a question like this? Here, picking your u also here is also important, alright? Because if you pick a wrong u, you end up deviating, alright? So now, here too, the u, if you let the u to be equal to, now here, clearly the u should be square root of s. But which of it? Is it this one or this one? Now don't forget that the power we have here is like an argument. So this is the one inside of what? Something. So we let that be equal to that. And the idea is that even if you let this to be equal to u, and you differentiate, none of the results can cancel what we have here. But when we set this to be equal to u, the results is probably to cancel this one so that it will help you in the solving. So here you get du over ds to be equal to, this is the same as this. So you get half s. So subtract this, subtract 1 from it, you get negative half. Alright, so here we get, simply we get 1 over 2 square root of what? S. So this is going to be du ds. So to make ds the subject, you get du multiplied by 2 square root of what? S. So let's go and do substitution. So by substitution, we are going to get integral of 3 raised to the power u over square root of s. Please, here is not u. Here is not going to give you u. Alright. So then we multiply by what? Ds. And we know that ds is what? Du multiplied by the square root of what? S. Sorry? Don't forget that the 2 is a constant, so that will come out. Alright? So this will take away this, so we get 2 integral of 3 raised to the power u over nothing. Over nothing. Du. Alright, so 2. Now the integral of this, you repeat this alright, but you take the mean of what? The constant, which is 3. Okay? Plus C. Alright, so here, finally, we are going to get 2, 3 raised to the power u, and the u is what? The u is square root of s over 3 plus c. So that's going to be your final answer for that. Trust you understand. Okay, so our next question is going to be also interesting. Well, okay, here it is. The integral of s plus 1 times 3 raised to the power s squared plus 2s ds. Very good. You have a very nice thing there. As we normally do, we set u, but what is going to be our u? Here, if you let your u be equal to this, imagine, none of the results is going to cancel something out. Because this is like an argument, alright? And that result can't go and cancel it. But imagine that when we let u to be equal to s squared plus 2s, look at the results. Du ds is 2s plus 2. Ooh. I hope you can see something. Now here, I hope you can see something. Let's go. Du is 2s plus 2 ds. Let me show you what I'm seeing in case you are not seeing. Now you can see that the s plus 1, when you do the substitution back, something has to cancel something. But the 2s plus 2 is not found in the integral function. So what can we do? Know that what we have here is the same as integral of 3s squared plus 2s times s plus 1 dx. Ooh! Hope you cannot see it. You can see that this is exactly du. That is exactly du. Oh, it's not exactly. Okay, don't worry. We can make it exactly. Factor 2 out. Nice. And what are you going to get? We are going to get s plus 1. How? This is exactly. So when we divide both sides by 2, we are going to get something like this. And this will clear off. So when you are rewriting it, instead of writing this, we can write du over 2. And the constant we have here is half. So we get the integral of. But don't also forget that what we have here, the whole of this is what? U. Welcome, welcome, welcome. We are now in the proper form. We are now in the proper form. So we can now go straight. In fact, please, you can make ds you can do substitution to ds, and it will clear it off. It's the same way as saying that this is the same as du over 2. It's the same thing. You haven't done anything. Alright, so here you repeat this, you take the mean of the 3. Don't punch that on calculator, just leave it because you'll be getting decimals. Then plus c. So this becomes, don't end it. Have 3 raised to the power s squared plus 2s s plus 1 oh, you can do what I'm doing. Then you can just s squared plus 2s so over 3 plus c, and that is all. And that is all. And that is all. Yes, that is all. Last question. Last question. Oh, I love calculus. Most especially calculus 2. And we have 3 raised to the power s over 1 plus ds. Last question. Yes, straightforward. Set u to be equal to 1 plus 3 raised to the power s. Du is equal to 3 raised to the power s ds. And we can see it on top that you can make ds the subject and when you can make ds the subject and go and do the substitution. You can also say that here is 1 over u. 1 over you can always say that here is 3 raised to the power x ds, okay, because we can multiply it by this. So here we end up getting, this is the same as du, so we get du over what u. That is all. And here we know that that is the same as 1 over u du. So we end up getting u plus c. So we know that u, you see that now it's speeding up. You know that u is equal to what? 1 plus 3 raised to the power s plus 1. And that and your results. Alright. Thank you. Thank you. So that is all for this video. Make sure you refer to our materials on our website. Okay? So that all. You can go to Google Play Store, search Math Experts. Math Experts. Math Experts. And you have a lot of materials there. You have it's an application, okay? So you have a lot of materials there to download and be solving more questions. So until then, bye bye.